All right, so we are going to do a calorimetry problem. So first we have our formula, which is MC delta T equals negative MC delta T. So the M is mass, the C is specific heat, and the delta T is change in temperature. So now we're going to assign all of our variables. So first we have a 28-gram sample of aluminum. That is mass, and since aluminum is a metal, that is, and since aluminum is a metal, we're going to put a little m subscript there. So the mass of that is 28.4 grams. Next, the sample of aluminum is heated to 39 degrees Celsius. So that is actually the initial temperature. So we're going to hold off to write that down. Then it is placed in a calorimeter containing 50 grams of water. So that is the mass of the water. So that's 50 grams, actually 50.0 grams. The temperature of water increases from 21 degrees Celsius to 23 degrees Celsius. So that's our initial and final temperature of water. So to get the change in water, we take 23, which is our final, minus 21, which is our initial, and that gives us 2 degrees Celsius. That is our change in temperature for water. And it's asking for the specific heat of aluminum. So we have specific heat of aluminum, which is C of metal, is our question mark. Now, our delta T for water, okay, so since we are putting delta T for metal, since we are putting the metal into the water, and the water increases from 21 to 23, that 23 is also going to be the final temperature of the metal. So our delta T for the metal is going to be final minus initial still, so it's 23 minus 39.4, and that turns out to be negative 16.4 degrees Celsius. Okay, now we need one more thing, and that is the C of water, which, as we hopefully know, is 4.184 joules per grams degrees Celsius. All right, so now we have to rearrange our equation. Like I said, we are looking for C of metal, okay? So we write our equation, MC delta T equals negative MC delta T, okay? So we're going to try to find C, okay? So we got to get all of the other stuff on the other side. So we divide both sides by M and delta T. So M and delta T over here cancel out, and we are left with MC delta T of water divided by MC delta T of metal equals negative C of metal. So now we just plug everything in. So, I'm going to run out of room there. Hold on. Let's erase this stuff. We're going to make that a little bit bigger. Okay, so now we have 50 grams times 4.184 times 2 degrees Celsius, that's all our water, divided by 28.4 grams, which is our metal, times negative 16.4 degrees Celsius, which is the temperature of our, or change in temperature of our metal, and that equals 0.898 joules per grams degrees Celsius. So that is our C of aluminum, and that is that.